Chapter 3, we're going to look at measures of central tendency. Most of these you should be familiar with. Those are your mean, your median, your mode, and your mid-range. Along with that, we're going to look at our weighted mean, and then that will also include some new calculations or calculating the mean for some new scenarios, calculating the mean for a grouped distribution. So we go down through here. The first thing we have to touch on is our rounding rule. We don't round any figures until all the computations are complete, and we round our final answer to one more decimal place in the given data. Pretty straightforward there. So basically, don't round anything as you're doing your calculations until you get to the final answer, and then round that to one more decimal place. The mean, by definition, is the sum of the values divided by the total number of values. Might be a new symbol here. This is called a summation sign. This archaic looking east type of symbol is a summation sign. So our mean, this is X bar. This is our sample mean, and mu, the Greek letter, is our population mean. They're both found doing the same thing. We sum all of our X values and divide that sum by our total number of terms. The sum of our X values divided by our total number of terms. But once again, X bar is a sample mean, and the mu is a population mean. From chapter 1, we should know the difference between a sample and a population. If we're trying to find the average ACT score of the kids at Waukee High School, everyone at Waukee High School will be the population of Waukee High School. A sample of that might be the ACT scores or average ACT scores of the kids that are in stats class. Okay, so a sampling of students. Next, you can see I have outlined here basically a step-by-step process to find the mean of a frequency distribution. So number 1, we find the midpoint of each class. Number 2, we multiply the frequency of each class by its midpoint. Number 3, we add those products together. And number 4, we take that total and divide it by the total number of frequencies. And we'll see that in action here in just a little bit. Well, that's a step-by-step process to find the mean of a distribution. The definition of a median, it's the midpoint of our data array. So to find the median, we arrange our terms in order from smallest to largest, and then we find the middle value. If there are an even number of terms, there will be 2 terms in the middle. We'll add those 2 terms together and divide by 2. The mode is the value that occurs most often. A data set may have more than one mode, or it may not have a mode at all. So if we have a list of numbers and no number occurs more than once, there is no mode. If we go to a group distribution, the modal class is simply the class with the largest number of frequencies. It can be expressed as the class boundaries, as the class limits, or it could be as a mode of the class midpoint. Mid-range is, just as the name implies, the middle of the range. That is the sum of the highest and lowest values added together and then divide that by 2. Make sure you know the difference between mid-range and range. Range is the spread, which we'll talk about in the next section. Range is highest minus lowest. Mid-range, or middle of the range, is the highest plus the lowest divided by 2. Weighted mean, oops, lost that. Weighted mean is if items have different values, an average is found by taking the corresponding, or multiplying each value by its corresponding weight and dividing by the sum of the product of the weight. Dividing the sum of the products by the sum of the weights. For example, some of us have taken AP classes. They might be figuring the GPA a little bit differently, so that would be a prime example of weighted mean. Or even for this class, with our homework being 10%, test being 75%, and final being 15%, each of those weights into the grade differently, so that would be an example of a weighted mean. What else do we have here? Looks like that's it. So we're going to find those values in different examples here. So let's find the mean cost of a 3-item pizza for these sample prices. To find the mean, we would add all these values together. So I'm going to show adding all those together, 625, 888, 763, and 850. We would add all those together first, and then we would divide that by the total number of values, 2, 4, 6, 8. There are 9 values, so we would divide by 9, and our mean then is $7.83. So the average cost of a 3-item pizza is $7.83. Okay, so that's our mean. Add all the terms together and divide by 2. Now the mean for a distribution like this is just a little bit different. This is our frequency column here. So the first thing we do to find the mean is I create another column for the midpoint. The midpoint is the midpoint of our class, so 35 plus 45 is 80 divided by 2. Our midpoint is 40. 46 plus 56 is 102. Our midpoint is 51. And we repeat that process all the way through 62, 73, 84, and 95. Those are our midpoints. We'd add one more column. That would be our frequency, this column right here, multiplied by that midpoint we just found. So here 2 times 40 is 80. 3 times 151 is 153. 4 times 62 is 248. 73 times 4, or times 8, sorry, is 584. 84 times 5 is 420. And 95 times 2 is 190. We're going to add that column up. If I add that column straight down, I get 1,675. To find our mean, 5, 9, 17, 24. Our mean is found by dividing that total, that's 1675, by our total number of frequencies, which is 24. So in this case, our average grade in the algebra class is about 69.8. Okay, so there's finding the mean of a grouped frequency distribution. We'll repeat that process one more time just so we're crystal clear here. Here's our frequencies. So the first thing we're going to do is create that column for the midpoint. Our midpoint between 0 and 4 is 2. Between 5 and 9 is 7, 12, 17, 22, 27, and 32. As we did up above, our next step is to take the frequency and multiply it by the midpoint. So 16 times 2 is 32. 21 times 7 is 147. 12 times 12 is 144. 17 times 11 is 187. 22 times 10 is 220. 27 times 8 is 216. And 32 times 2 is 64. We're going to add that column together. That gives us a total of 1010. We're going to add our frequency column together to a sample of 80 college professors, so we have 80 total frequencies. And then our mean is found by taking the 1010 and dividing it by our total number of frequencies, or in this case, we have an average of about 12.6 years of teaching experience for our college professors. Okay, so there's our mean of a grouped frequency distribution. Let's continue on, find the median cost of the speeding tickets. So a median, the first thing we have to do is put these numbers in order from smallest to largest. So my smallest number is 25. I then have a 30. I have a 35. Looks like a 40. 50. A 55. A 60. 65. A couple of 70s. And a 95. Oh, 2, 4, 6, 8, 9, 2, 4, 6, 8, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have all 11 numbers listed there. To find the median, I want the middle term, so I'm just going to go through and knock one term off of each end until I get to one term left in the middle. And you can see here, the term left in the middle is 55. That is our median. All right, so median again is the middle term. Let's try that process again. This time I think we'll have an even number of terms. That way we can see that. So I put these numbers in order from smallest to largest. I have a 0, a couple of 1s. Looks like there are 3 2s there. 3 3s, 1, 2, 3, a 4, and a couple of 6s. 3, 6, 9, 12. So we have 12 total terms there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have all 12 listed. If we follow the same process of knocking one term from each end until we get down to the middle, you can see we get down to the point where we have 2 terms left in the middle. So we find the median by adding those 2 terms together, 2 plus 3, and dividing it by half or by 2. So my median in this case is 2.5. The middle term is 2.5. As we continue on here, the mode and the mid-range. So the mode is simply the number that occurs most often. As we glance through here, it looks like 70 occurs twice. It's the only number that occurs more than once, so 70 is our mode. Our mid-range is our highest plus our lowest divided by 2. So my lowest number is 25. My highest number is 95. If I add those two together and divide by 2, just to make sure our calculator operations go okay, I'm going to put parentheses around that. 25 plus 95 is 120. 120 divided by 2 is $60. So our mid-range is $60. Let's go through that again here with our time spent on a computer per day. So our mode and our mid-range. Our mode is the number that occurs most often. Notice that 2 occurs 3 times, but 3 also occurs 3 times. So our mode is both 2 and 3. And our mid-range is the lowest term, which is 0, plus the highest term, which is 6, divided by 2, or our middle of our range is 3. Moving on, our modal class. Our modal class is found simply by looking for the class with the highest number of frequencies. You can see right here, this is our largest number of frequencies, so that's class 5 to 9. So our modal class is just that. It's 5 to 9. Now that can be expressed 3 different ways. So 5 to 9 is one way. 4.5, not working very well for me here. So let's try again. 4.5 to 9.5 is the boundaries. That's another way of saying the modal class. Or we can just say it has a mode of the midpoint. The midpoint from 5 to 9 is 7. So our modal class is 5 to 9, or 4.5 to 9.5, or our mode is just the number 7. Looks like we'll see that again here. Nope. Looks like we're going on to weighted mean. So tickets for a concert were priced at different amounts depending on the seating and how far in advance the tickets were purchased. For the amounts listed below and how many at each price, find the mean cost of the tickets. This one we already have labeled with the X and the W. So to find our weighted mean, the first thing we do is multiply the weights times their values. So 400 times 10 is 4,000. 15 times 300 is 4,500. 450 times 20 is 9,000. 25 times 2 is 5,000. And 50 times 50 is 2,500. We're going to total that column. If we add that column together, we get our total to be 25,000. In other words, they sold $25,000 worth of tickets. Now with our weighted mean, it's a little bit tricky here. This one's marked, so it's a little bit easier to see. But I'm going to go back up here. It says find the mean cost of the tickets. I'm going to reword that. That is the mean cost per ticket. Basically the same statement, just with a different format. because per is a word that we might be familiar with in math. Per means to divide. So in other words, I want to take my cost and divide it by my number of tickets to find my weighted mean. So I have 700, 1150, 1350. We've sold 1,400 tickets in total. So our weighted mean, or our mean, is that 25,000 sold in tickets divided by the 1,400 tickets. Our average cost per ticket is $17.86. Okay, so there's how we're going to determine what to divide by, whether it's price or tickets. We're going to divide by rewriting it mean cost per ticket, and that will give us the average cost of a particular ticket. We'll see that one more time here. Find the mean age for children in a 4th grade class. So you can see we have 4 different ages, and we have these number of students. So I'm simply going to multiply those together. I'll go ahead and label that as x times w, even though we don't know which one's which. 8 times 2 is 16. 9 times 10 is 90. 8 times 10 is 80. And 5 times 11 is 55. If I total that column up, I get 241. So then the question comes, do I divide by the number of students or do I divide by their ages? So I'm going to go back up here. It says find the mean age for children in a 4th grade class. So the mean age of a child or the mean age per student. So in this case, I want to divide by my number of students. There are 25 total students. 241 divided by 25 gives me an average age of 9.6 years. That would be our weighted mean. So there we've had a mean of a set of numbers, a mean of a group distribution. We found the median of a data array or a set of numbers, the mode, the mid-range of a set of numbers, the modal class, and finally the weighted mean. That should cover our measures of central tendency or the measures of the center.